Let's review and give a summary about the charts we learned. So far, we learned 4 different charts. We have line graph, scatter plot, bar chart, histogram. So the line chart and the scatter plot and histogram, they're all working on the numerical attribute. But one thing is, histogram only work on one numerical variable. So line graph or scatter plot work on 2 numerical attributes. The difference between line graph and scatter plot. Line graph, one of the numerical attributes have the sequential data. Usually it's over time we see most commonly. For example, over the years. And sometimes we say they also like over the distance. So that's the line graph. So if your numerical attribute, they don't really have sequential data, then we may consider use the scatter plot. So scatter plot, the same thing, work with the 2 numerical variables, but we try to find also their relations. So according to the plot, because each point is using the x and y, so to see the distribution of those scattered, so then we will see the trend to find the relation and see how the association between these 2 numerical variables. So the bar chart is the one we work on the categorical distribution. So you have find the distribution of one categorical variable or a relation between a categorical and the numerical variable. So one thing is, because you have one axis, they're using the categorical data, and also the width for the interval is the same. So either the height of the bar or area of the bar represent that numerical variable. Histogram will be similar. The appearance look like bars, but it represent the distribution for one numerical variable. So remember, if using the histogram chart, we need to have this numerical variable put into group, use the bin. So one thing is the bin's interval may not be the same. That means the width for each bar will not be the same. So the area and the height and the width is very important meaning for the histogram. So after you know those charts about the summary for that, let's do one example. Because when we want to visualize data, we need to really know what kind of chart we want to use. So if you have a data about the daily temperature, we show here. Of course, we have a couple hundred rows, but we only show the first 3. So you can see on so you can see that yearly, because you have 3 days plus 362. Total, we have 365 days. Each day, they have the low and high temperature, and we have the sky condition. So which type of chart would show the answer to each question here? So you have 3 questions. Are there more cloudy than sunny days? What the percent of the days have a height at least 72 degrees? Do days with hotter highs tend to have harder lows? So I want you to think about that. So pause the video to see the table and read the question. Then we will talk about the answer. So please make sure you pause the video because right away to think about that. Otherwise, right away I will give you the answer. You can discuss with your group or any friends you study together. Have a discussion. Then I will give you the answer. In 3, 2, 1. So about the answer, let's see the first one. Are there more cloudy than sunny days? So sunny day and cloudy day, we see the sky condition. Okay, so that's this column we are looking for. So this column, the data is categorical data or numerical data. Right, categorical data, right? So categorical data, we want to see the distribution, right? We need to use the bar chart. The second one, what percentage of days has a height at least 72 degrees? So we only working on which column? Right, the height column. So the height column only, right, so we're looking for the 72 degree. So that's working on one numerical attribute. So that will be the histogram. So histogram, after you plot the histogram, make sure you have the one interval boundary is 72 degree. So after the 72 degree, we find the area for that bar, the older bar, if you have more than one interval over 72 degree. So the area of the bars, then that will be the total percent for the days with the height over 72 degree. So the last one, do days with harder heights tend to have harder lows? So again, what the column we're looking for? So we have heights, we have the lows. So we care about the height and the low column. So these two columns are both numerical data. And they kind of not really have the sequential moving. So that's why we better use the scatter plot. So then we see the trend. If they have the harder, that means the harder height. So that means the higher heights tend to have higher lows. So then we try to see on the left-hand side for the scatter plot, we will have more dots in the lower side. So the right side, we will have a height right side. They should have more scatter. So that's the relationship between that. Okay, so that's our review for the chart. So the second part of our lecture, we want to talk about functions. So we talk about functions, but those functions we use, they are either built-in functions or the functions from different module or class. Like you see the NumPy, we have the different function we can call. But here we call the defining function. That means we will have the user-defined function. So you can define your own function how you want to use for that. So the user-defined function in Python, they have the format like this. Okay, so the structure for the function, the first thing you have the two keywords, that diff, define, and return. So make sure you have these two keywords. So then before the column, you need to specify the name of the function. So of course, the name of function is user-defined. So you need to create, you want to name your function name is meaningful for your function. Depends on what your function want to do. So then after the function name, you have percentage. You have, the parentheses. So inside the parentheses, you can specify the argument name. Again, the same thing. The argument name is user-defined name. So you can use your own name to create that. So then when you return, you see the expression here, you can return including the variable you want to define, you want to return, or in this return, you can have any expression. So for example, this one actually we can call to built-in function. After user pass the argument values, we will return the maxima for the values minus the minima of the values. So that's the function defined. So that's really still an example of how to define a function, so we have better idea. So this example, that's create a function. We say example create a function that take a numerical input and triple it. Okay, so for example, they look like this. That's mean I call the function triple, pass the value. This one is usually numerical data because you know the numerical data you can multiply by that. So the result, they will return you 3 times the value you're passing. So how to define that? Like earlier we say, when you define a function in Python, 2 keyword def, then return. So here is the function name. Since we already told you the function name is triple, so then parentheses the x. The x just because here they told you x, yeah. So then we just use the variable x. But honestly, depends on how you like that. If you want to change to y, just change here is y and here 3 times y. Okay, so here let's just use the x. Okay, so after you define, make sure you still need to run. So that's in Jupyter Notebook. Okay, so then after you define the function, we're passing 3. So you are expecting what display? Yeah, we will get 3 times 3 is 9, right? Okay, so you can either, after you define the function, here's the value you're passing. Okay, so you can either pass just the rect value, or you can assign another variable called num, content 4. So then when we have code passing the num to the function, they will give you the value as well. So, but remember, after you write that, make sure you run. Then, of course, 3 times 4 is 14. So after you have your num is 4, right? Yeah, you can times 5. That's passing like 20. But 20, you still need to triple that. So that will be 60. So that's the example for defining function. But one thing is, be careful. The x here, just the parameter, just the argument using for this function. So if we try to add one more cell before that, okay, so you can see here, if we try to see what is x, yeah, x is not defined, even after we define the function. Okay, when you see the x, then when you try to run, yeah, you don't have x. So x actually in the function defined, the variable you use, the argument variable you use, they're only in this scale. They are not outside that. Okay, so be careful about that. So the anatomy of a function, remember return and diff, the two keywords, very important. So even earlier we defined the triple, right? Even we say here, right, is create a function, take a numerical input. But once you create this function, because in Python, your x, the name, they can be any data type. Okay, so that's why if we passing a string, you guess what happened? Yeah, they still give you the string. Yeah, string actually you can multiply as well. They will give you the 3 cent string. Okay, or you can create an array. So when we create an array, use a range function 4. That means we have 0, 1, 2, 3. Then if you pass in an array to the triple, it just triple each element. Okay, so that's the function. I still have 1.5 minutes can record in this video. So that's talk about the discussion question. If I don't have time to have the answer, that will be in the next video. So in this discussion question, let's talk about function. So if I define one function like this, okay, we call f. That's just temporary. But later, after you understand the meaning, I want you to change the name. Okay, so you pass in a s. Okay, but you return what? You return numpy function. Numpy function do what? S divided by sum of s. So you have the sum of s. That usually means this s not only one numerical data, right? So you have multiple numerical data. That means actually this x usually should be an array. Okay, so then that means your total for each element in the array, using each one to divide by that. Then we times 100. Right, you try to make the percentage for each element. So since we're using the round function from the numpy, so they round to the second decimal place. So that's the meaning for this function, right? So according to that, what do you think that's the best function name for f to replace? So think about that. The good thing is the video will be done within 15 minutes. So then we will see the answer in the next video. So think about that and discuss with your classmates and try to write that as well before you see the answer.